we have to calculate the force, the towing force required to move the car if the back brakes are locked and the front wheels are free to roll. So what that means is that there is a friction force here, let's call this FB, but no friction force in A. And then here we have, of course, the normal force. We have been calling it NA, and then here we have NB, and then it tells me that the weight, well, that the mass is 2,000 kilograms. So 2,000 kilograms times 9.81 meters per second square equals 19,620 newtons, or 19.6 kilonewtons. Okay, so we have to calculate this towing force, and every time you have this kind of situation, then you'll know that you have a system of equations. Okay, now if you look at this, you say I have 1, 2, 3, 4, so I need 4 equations, and the 4 equations would be, in this case we have that 4th equation because the question is the force required to move the car. So it's the force required to start impending motion, which means that in the case of this force, the 4th equation tells me that it's ms times the normal force in B. Okay? So, which is the maximum friction force. So we'll have a system of equations, and the first equation is sum of the forces in X equals 0, and we have minus F, and we have cosine of 30, and then plus FB equals 0. We have sum of the forces in Y equals 0, and that would be F sine of 30, and then we have plus an A minus 19.6 plus NB equals 0. And then the next equation would be sum of the moments, and let's make it here about A to have it in terms of B. Sum of the moments at A equals 0, and so we have F sine of 30, and the distance is 0.75, and this would be positive moment, and then the next one would be F cosine of 30, and this would be 0.3, and this let me see, sine would be negative here, so here would be negative, I'm sorry, because this would make rotate up, and then this would be positive, and then we have the weight, which is 19.6, and the distance is 1, and this would be negative, and then the other would be positive, and B times 2.5 meters. This equals 0. The 4th equation, remember then, is that F B equals 0.3 times MB. So you have a system of equations, and we saw this in one of the presentations in the class. and I told you we could use some of the simultaneous equations. In the exam, mostly I would give you the F value, and you can tell me if you can move the car or not. So by solving these simultaneous equations, what we will obtain is that F, which is the question, the towing force, equals 2.76 kilonewtons, and A equals 10.3 kilonewtons, and MB equals 2.39 kilonewtons. So basically that's that problem. Now let's talk briefly about the bending moments and shear diagram. So in this specific case, we have to calculate the support reactions, and I'm going to sort of skip that procedure. But what we have here is By is 5 kilonewtons, and you have a moment here of 11 kilonewtons meter. So in this case, we have the 0 for the shear diagram. So we start in 0, and then you have the negative 2, and the shear does not change until you get here, and then from here what you have is the shear, and the difference in shear would be the area under this curve. So this here would be 1.5 times 2, so 3 kilonewtons, and this difference here is minus 3, so it goes from minus 2, and plus minus 3 would be minus 5. So this would go here to minus 5, and then of course then you have this 5, so you start in 0 and end in 0. So here is the shear diagram, and then this is a straight line. It doesn't look like a straight line, but it is a straight line. Okay, so that is the shear diagram. Now let's do the bending moment, and in the shear diagram what you see is that if there's no loads in here, you have a constant shear. Now we'll do the moment, and we start here in 0, and then there's no moment in this corner here. But what you can see is that if you were moving along this way, the moment is going to increase in absolute value. It can be positive or negative, but it'll increase because as you're increasing the distance here, the moment increases along the beam in this direction. So you know that it has to increase. And here I have this area here, and this area here is 2 times 2, which is 4. It's a negative 4, the area. So when I come here, the next level would be that I have here, and starting in 0, I'll have here a negative 4, and it's going to be a straight line. Okay, the area, the change in area under the moment is going to be equal to negative 4. So now I have to a negative 4 here, and there's going to be a change in moment from this point to that point. So I know that this has to go either like this or like this, and that's what we'll have to check. What slope is that? And you know, the easiest way is to find one point in between, draw it more or less to scale, and then get to calculate if it's concave up or down. So in this case here, the area under this curve, you have this is -4, so you have 2 plus 5 divided by 2 times 2, and this is a negative value here, and this area under the shear diagram is -7. So then I know that this change will be from -4 to -4 plus -7, so it'll go to -11. Now the question is if it's concave up or down. And really, in this case, what you need to remember is that in the pictures, and let me see if we have it here, in these cases that we have here, they tell you more or less what is the shape. So if the shear diagram has this slope, then it's concave down. If it was in a different shape, that it was like this, then you would have it in the opposite direction. So basically, this tells you, but again, I'm not expecting you to memorize all of this. So we'll just do a pointer in this case, then it would go like this, and this would be the area under the moment. So another way to do this exercise, it could ask you for the shear moment and bending diagram at any point, or what is the maximum shear? Well, in this case, the maximum shear, you look at the graph and it's -5. What is the maximum moment? Well, the maximum moment is -11. Now I know that this is -11 because it has to go back to 0, and I have a moment of 11, so I have to start in 0 and end in 0. So let's take, for example, the situation. You have 2 kilonewtons. So remember, you have this situation. So this is your shear, your normal force, and your moment. So you calculate it at the point where they tell you to calculate it using statics. So this really reviews what I just said about the area under the loading curve and the area under the shear. So I hope this is helpful. Thank you.